Hello everyone. Okay, so in this video we're going to be looking over the factor theorem and then solving cubic equations or finding the roots of cubic equations. So recall a factor is something that divides in evenly with no remainder. So something is considered a factor if I can divide it in and I get no remainder out of it. So a polynomial will have the same number of factors as its degree. So remember, the degree of a polynomial is the highest power. So a quadratic equation and a quadratic x squared is the highest power. So 2 is the highest power, so 2 its degree. So a quadratic will have 2 factors, a cubic will have 3 factors or 3 solutions, etc., etc. A root of equation is the value for x for which we sub it in for a function fx. The root is a value for which f of x equals 0. So when we sub in a value of x, my function equals 0. And then on a graph, a root is where the curve crosses the x-axis, or i.e. where y equals 0. So what is the factor theorem? So the factor theorem tells us is if x minus a is a factor of a given function, x equals a is a root or solution to that equation. That's it. We've done this already before, right? When we're solving quadratic equations, like we just let the factors equal 0, and then we solve it for x, and then that is our root. That is our new solution. So conversely just means like oppositely, or like vice versa. If we're given a root from an equation, say x equals a, then therefore we can form a root from it and say x minus a is a root factor. So form a factor, and it's a factor of this equation, and we'll divide in evenly into our equation. That's it. That's all you need to know. We've done this. You've known this before with quadratic equations. We're just putting a name onto it now. So we're going to use the factor theorem. So, investigate if x plus 3 is a factor of x to the power 4 plus 2x cubed minus 25x squared minus 26x plus 120. So, x plus 3 is a factor, so therefore x equals minus 3 is a root. So that is via factor theorem. So, if I sub in x minus 3 here, this should equal 0. So, sub in x is minus 3. So, minus 3 to the power 4 plus 2 times minus 3 cubed minus 25 times minus 3 squared minus 26 times minus 3 plus 120. Add it all up, put in your calculator, you're going to get 0. So therefore, by factor theorem, x plus 3 is a factor. Note, we could have also used algebraic division and found out that x plus 3 divides in evenly, but after that, why would we do division when we can just sub things into our calculator, you know what I mean? Right, so how does this help us solve cubic equations? So, we are going to learn how to factorize cubic equations. So, this is how we factorize and solve cubic equations or higher order polynomials. So, using trial and error, we're going to find a root of a polynomial by subbing in factors of the constant term. So, what we do is, we get the constant term, i.e. the term with no x, we find factors of that, we sub it into my equation to find which one is a root of the entire equation. So then we're going to rewrite this root as a factor using the factor theorem. Then we're going to divide the polynomial by this factor, and then solve the resulting equation to find the remaining factors. So, as I said, it's much easier if I do rather than say. So, factorize fully 3x cubed minus 19x squared plus 33x minus 9, and then solve that equation. So, first of all, using trial and error, I'm going to sub in factors of minus 9. So remember, factors of minus 9, that'll be plus or minus 1, plus or minus 3, or plus or minus 9. Right, so if you sub all that stuff in, you'll find that we try and x equals 1, that doesn't work. X equals 3, that does work, right? So it's usually kind of on the lower end. It's usually in your exam, it'll always be like x is 1, 2, or 3. They won't be an asshole and like ask you for a bit more, you know what I mean? So therefore, using factor theorem, x equals 3 is a root, therefore x minus 3 is a factor via factor theorem. Now we divide this factor in to get the other factors. So we've done this before already in second year and also in Algebra 1. So 3x cubed minus 19x squared plus 33x minus 9. So divide this in. So 3x cubed divided by x is 3x squared. 3x squared times x is 3x cubed. 3x squared times minus 3 is minus 9x squared. Change the signs. Plus, minus, that goes to a 0. This goes to a minus 10x squared, bring down the plus 33x. It's plus 33, isn't it? Yes. Minus 10x squared divided by x equals minus 10x. Minus 10 up on top here. Minus 10 times x is minus 10x squared. Minus 10 times minus 3 is plus 30x. Plus, minus, change the signs, that goes to 0. This goes to plus 3x. Then bring down the minus 9. Finally, 3x divided by x equals 3. 3 times x is 3x. 3 times minus 9 is minus 3 is minus 9. Plus minus 0, 0. Therefore, 3x cubed minus 19x squared plus 33x minus 9 is equal to x minus 3 times 3x squared minus 10x plus 3. So it's a factor. So that's to fully factorize. This is going to be x minus 3. And if I factorize this quadratic, I'm left with 3x minus 1 times x minus 3. So you can factorize that yourselves, but that's what I'm going to get as. And then this fully factorized is this. So 3x cubed plus 19x squared plus 33x plus 9 is equal to x minus 3 times 3x minus 1 times x minus 3. Right. Now, but it's asking us to solve. So it's the same process when we're solving quadratic equations. I let each bracket equal 0. So I'm going to have x minus 3 equals 0. 3x minus 1 equals 0. And x minus 3 equals 0. So I'm going to have x is equal to plus 3. That's my first solution. 3x equals 1. X is equal to 1 over 3. That is my second solution. And then x is going to equal to positive 3. So that's a minus 3 there. X is going to equal to positive 3. That's my third solution. So see here. This cubic equation, now x equals 3, it has a repeated root, right? So we're going to do more in this next section, but it's going to look like something like this. So it is a positive, so it's going to look like this, ding, 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 right? It's going to look something like this because it crosses at x is equal to 1/3. And it repeats at x is equal to 3. Right, so they are my 3 solutions to that cubic equation. And that's it. That's all we need to do in your exam. They love to ask this. Don't throw easy marks away. So let's do some questions. So 2022 Leaving Cert paper 1, question 5, BI. So again, this came up very recently, and they love to ask it. So f of x equals 2x cubed minus 21x squared plus 40x plus 63, where x is an element of real numbers. So x plus 1 is a factor. Find 3 values for x, which f of x equals 0. So i.e. solve the cubic equation. So x plus 1 is a factor. So x plus 1 divided into 2x cubed minus 21x squared plus 40x plus 63. There's going to be 2x cubed divided by x is 2x squared. Put it on top. 2x squared times x is 2x cubed. 2x squared times 1 is 2x squared. Minus, minus. It's going to go to 0. Minus 23x squared. Bring down to 40x. Right, repeat the process. Minus 23x squared divided by x equals minus 23. Minus 23x, I should say. Minus 23x, minus 23x squared. Minus 3x times 1 is minus 23x. So plus or minus, plus, and I'm going to have here 63x. Bring down the plus 63 here. Finally, 63x divided by x equals 63. Put it on top. I'm going to have 63x plus 63 minus minus 0, 0. So 2x cubed minus 21x squared plus 40x plus 63 is equal to x plus 1 times 2x squared minus 23x plus 63. So I just need to solve these now. So x equals minus 1. That's the first solution. Right? Let this bracket equal 0, or i.e. solve for that quadratic. And we're going to get here. Sorry, let me just sub it in here on my calculator. Right, so my A is 2, my B is minus 23, and my C is 53. So I'm going to get here, so I have x is minus 1, and then the two solutions to this quadratic here is going to be x is equal to 7, and x is equal to 4.5. And they are the three solutions to that quadratic there. Right. Let's have a look at the other one here. This is from 2021. So x plus 4 is a factor of x cubed plus qx squared minus 22x plus 56, where x is a real number, q is an integer. So if you don't get a whole number solution here, you're probably wrong for q. Show that q is equal to minus 5, and then find the three roots of f of x. So I want to prove that q is minus 5. So I want to solve for missing coefficient here. So I'm going to sub in. So if x plus 4 is a factor, therefore x is equal to minus 4 is a root. So therefore, when I sub in x is minus 4 into this equation, I should get 0. So minus 4 cubed plus q times minus 4 squared minus 22 times minus 4 plus 56 equals 0. I'm going to get here minus 64 plus 16q plus 88 plus 56 equals 0. I'm going to get 16q is equal to plus 80. 16q is going to be equal to minus 80. Q then is going to be equal to minus 80 divided by 16, which is minus 5. So therefore, I've proven that q is equal to minus 5. But now it's asking us here, find the three roots of the equation of f of x. It's asking us to find the three roots. So x plus 4 is a factor, so I'm going to divide it into this polynomial here. So x plus 4 divided into x cubed minus 5x squared minus 22x plus 56. So x cubed divided by x equals x squared. Put that on top. X squared times x is x cubed. X squared times 4 is 4x squared. Minus 0 minus 9x squared. Minus 9x squared divided by x is equal to minus 9x. Put that on top. Minus 9x times 9 is minus 9x squared. Oh, and I bring down the minus 22x here. Minus 9 times 4 is minus 36x. Plus 0. This is going to be plus 14. X. Bring down to 56. Now I'm left here 14x divided by x is equal to 14. Put the 14 on top. I'm going to get 14x. 14 times 4 is 56. Change the signs. Minus 0, 0. Done. So therefore, x plus 4 times x squared minus 9x plus 14 equals x cubed minus 5x squared minus 22x plus 56. So, fully factorize this. I'm going to have x plus 4 times x minus 7 times x minus 2 is equal to x cubed minus 5x squared minus 22x plus 56. So let each bracket equal 0. I'm going to get here, as my first solution, x equals minus 4. X equals 7. And x is equal to 2. And they are my 3 solutions to this. And remember, you can always check your solutions by subbing it in, right? Okay, so we have 2 questions left here. So this is the 2019 Leaving Cert Higher Level. This is from paper 1, question 4b. So we're given a graph of a cubic equation here. So part of the cubic equation, f of x equals 2x cubed minus 27x squared plus 109x minus 126 is shown below. The graph plus the x-axis at the point 2, 0, b, and c. So these are all solutions to my cubic equation. So b and c here are both roots, right? And I have one root here, so x is going to equal 2. So I need to find what b and c are. Well, if x equals 2 is a root, from factor theorem, x minus 2 is a factor. So I have a factor, I have my cubic, I'm going to divide in, and I'm going to solve for the remaining roots. So x minus 2 divided by 2, x cubed minus 27x squared plus 109x minus 126. Right, divide in. 2x cubed divided by x was 2x squared. 2x squared times x is 2x cubed minus 4x squared plus minus, so that's going to be 0. This is going to be minus 23x squared. Bring down 109x plus 109x. Minus 23x squared divided by x equals minus 23x. Put that on top. Minus 23x times x is minus 23x squared. Minus 23x times minus 2 is plus 46x. Minus plus, that's going to go to 0. This is going to go to 109x minus 46x is going to give me 63x. Bring down the minus 126. 63x divided by x is 63. Put it on top. 63 times x is 63x. 63 times minus 2 is minus 126. Plus minus 0, 0. So therefore, 2x squared minus 23x plus 68 is another factor. So x minus 2 times 2x squared minus 23x plus 63 equals 2x cubed minus 27x squared plus 109x minus 126. So I have now fully factorized my cubic equation now. So let me just factorize it fully. So x minus 2 times this is going to be equal to 2x x 63, 7 and 9. Yes, so that's going to be minus 9 here, minus 7 here. Right, so I want to solve this now. I want to solve this. So I'm going to let each bracket equal 0. So x equals 2 is one solution. 2x minus 9 equals 0. 2x equals 9. X equals 9 over 2. Other solution. And x minus 7 equals 0. X is equal to 7 is my final solution there. So to ask us to identify what B and C are, oopsie daisy, hate when this happens, really embarrassing. Spoilers. So find the coordinates of point B and the point C. So it crosses at 2, 9 over 2, which is 4.5, and 7. So B comes before C, so therefore this has to be 9 over 2, 0. And then 7 is the largest number, and C is the furthest away from the origin. So this point has to be 7, 0. And there you go. There you go. I found the coordinates of B and C. So it's 9 over 2, 0, and then C is equal to 7, 0. Right, let's look at the last question here. This is from 2014. A cubic function f is defined for x an element of or as x cubed plus 1 minus k squared x plus k, where k is a constant. Show that minus k is a root. So if x equals minus k, so f of minus k equals 0. So when I sub in minus k here, I should get 0. So minus k, all to be cubed, plus 1 minus k squared times minus k plus k. So minus k cubed is just going to be minus k cubed, plus minus k times 1 is minus k. Minus k times minus k squared is going to give me plus k cubed. And then plus k here. Does this equal 0? Yes, it does. Because minus k cubed plus k cubed, they cancel out. And minus k plus k also cancels out. So 0 equals 0. Therefore, x equals minus k is a root. Sorted. Find, in terms of k, the other two roots of f. So I want to find, in terms of k, the other two roots. So I know x equals minus k is a root. Therefore, x plus k is a factor. So let's divide it in. So x plus k divided into x cubed plus 0x squared plus 1 minus k squared x plus k. So x cubed divided by x is x squared. Put that on top. X squared times x is x cubed. X squared times k is plus kx squared. Minus minus, that goes to 0. Minus kx squared. Bring down this plus 1 minus k squared x. So we rewrite that bottom line there. It's a bit messy. So minus kx squared plus 1 minus k squared x. I have minus kx squared divided by x is minus kx. Minus kx times x is minus kx squared. Minus kx times k is minus k squared x. Plus, that goes to 0. I'm going to have here, it's going to be x minus k squared x plus k squared x. That's going to go cancel out. So I'm just left with normal x here. Then finally bring down the plus k. Bring down the plus k, and we'll have x divided by x is equal to 1. Put that on top. 1 times x, 1 times k is k. Minus, minus, 0, 0. So, x squared minus kx plus 1 is my quadratic. I now need to solve this quadratic in terms of k to find the other two roots of f. So you could just kind of sub it into your minus b formula, really. So solve in terms of k. So a equals 1, b equals minus k, and c is equal to 1. So minus b plus or minus, so it's going to be positive k plus or minus b squared, so k squared minus 4 times a, which is 1, times c, which is 1, all over 2. K plus or minus root k squared minus 4 all over 2. They are my other two roots, right, in terms of k. K plus or minus root k squared minus 4 all over 2. Right, finally, part C is find the set of values for k for which f of x, which the function f has exactly one real root. So we're actually going back now to my nature of roots here. So one real root, remember my discriminant, b squared minus 4ac equals 0. So what's my discriminant? Well, I got it in part 2, k squared minus 4. So therefore, k squared minus 4 equals 0. K is going to equal 4. So k squared is equal to 4. K is going to equal to plus or minus the square root of 4. K is going to equal to plus or minus 2. And that is my set of values there. So k can be plus 2 or k can be minus 2. Right, and that's us done there for solving cubics. I hope this video was some help. Long one. Happy Halloween, and I'll catch you guys later. Bye.